Hello everyone, myself Riya Jain. My roll number is IT2K2049 and this video is a part of my assignment given to us by Dr. Shaligram Prajapat sir. And in this video, I am going to provide the solution of third internal test paper. This test paper is of objective type. First is in Stressen's matrix multiplication, the number of matrix multiplication needed to multiply 2 into 2 matrix is option B 6. Second, the Huffman code is a type of option A lossless compression algorithm. Third, in Kruskal's algorithm, what is the time complexity for sorting the edges of the graph? Option B order of n log n. Fourth, in Prim's algorithm, what is the time complexity for finding the minimum weight edge from a vertex? Option A, order of n. Fifth, depth first search can be used to find option B, the longest path between two nodes in a graph. Sixth, BFS can be used to find option A, the shortest path between two nodes in a graph. Seventh, dynamic programming can be used to solve problems that exhibit option A, optimal substructure and overlapping subproblem. Eighth, the matrix chain multiplication can be solved using A, dynamic programming. Ninth, the longest common subsequence problem can be solved using option A, dynamic programming. 10th, in Stressen's algorithm, the matrix to be multiplied are divided into option B, two equal parts. 11th, Huffman code are prefix codes, which means that option C, all nodes have the same length. 13th, the minimum number of bits required to represent the symbols in a set using a Huffman code is option B, less than the number of symbols. 14th, what is the time complexity of the standard matrix multiplication algorithm? Option D, order of n cube. 15th, in Stressen's algorithm, what is the base case for the recursive algorithm? Option A, when the matrices are 1 cross 1. 16th, the Huffman code assigns shorter codes to option A, symbols with high probability. 17th, in Kruskal's algorithm, how many times are the edges of the graph sorted? Option A, once. 18th, Prim's algorithm can be used to find the minimum spanning tree of option A, undirected graphs. 17th, the time complexity of BFS is option A, order of n. The time complexity of DFS is option A, order of n. What is the time complexity of dynamic programming approach for solving the longest common subsequence problem? Option B, order of n square. 22nd, in the matrix chain multiplication problem, the number of matrices to be multiplied is option A, given as an input to the algorithm. 23rd, what is the time complexity of the dynamic programming approach for solving the matrix chain multiplication problem? Option D, order of n cube. 24, which of the following algorithm uses a greedy approach? Option A, Kruskal's algorithm. 25, the longest common subsequence problem can be used to solve option B, DNA sequencing problem. 26, the running time of the Stressen's algorithm is faster than the standard matrix multiplication algorithm for the matrices of size option D, 4 cross 4. 27, in the Huffman code, the average length of a code word is option B, less than the number of symbols. 28, what is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem? Option B, order of n cube. 29th, what is the maximum number of subproblems that needs to be solved in a dynamic programming approach for matrix chain multiplication problem for n matrices? Option C, n square. 30. In dynamic programming approach to solve the longest common subsequence problem, what is the recurrence relation used to calculate the length of the LCS? Option B, LCS of I, comma j is equals to max of LCS of I minus 1 into j, comma LCS of I j minus 1 if x of I is not equals to y of j. 31. In the dynamic programming approach to solve the longest common subsequence problem, what is the time complexity to print the LCS? Option A, order of n. 32. What is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices? Option B, order of n cube. 33. What is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices using memoization? Option D, order of 2 to the power n. 34. Which of the following algorithm can be used to solve the longest common subsequence problem? Option D, dynamic programming. 35. Which of the following algorithm can be used to solve the matrix chain multiplication problem? Option D, dynamic programming. 36. In the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplications required to multiply n matrices? Option B, m of 0 into n minus 1. 37. In the dynamic programming approach to solve the matrix chain multiplication problem, what is the minimum number of scalar multiplications required to multiply a chain of length n minus 1? Option B, m of 0 n minus 1. 38. Which of the following is not a subproblem of the dynamic programming approach to solve the longest common subsequence problem? Option D, LCS of I plus 1, j plus 1. 39. The dynamic programming approach to solve the longest common subsequence problem has a time complexity of option A, order of n square. What is the difference between Prim's algorithm and Kruskal's algorithm for finding the minimum spanning tree of a graph? Option D, all the above. Thank you for watching.